Hey guys, Mr. Backerberg here. In this video, we're going to look at solving some equations that don't initially look quadratic, but they will involve some quadratic techniques. So as we're taking a look at this first example, we want to solve the equation 1 over x plus 1 over x minus 1 equals 7 over 12. Now, because our equation has fractions in there with variables in the denominator, we do need to be careful about the domain. And remember, the domain is the set of x values that are safe to plug in. So we would want to think about what values are not safe to plug in for x. And remember, we never want to have 0 on the bottom of the fraction. So as we take a look at this first fraction, because we've got just a plain x down there, 0 would be bad to plug in. So we don't want our x value to be 0. And as we take a look at our second fraction, the value that would give us 0 on the bottom would be if we plugged in an x value of 1. So we also don't want our x value to be 1. So as we're solving this equation, we're going to look out for those two x values just because if we do get those as an answer, we would need to exclude them. Now, solving this equation with the fractions in there can be a little bit tricky. So what we want to think about doing is a little bit of multiplying that's actually going to help us get rid of all of these fractions. So I'm going to look at the denominators that we've got here. And what I actually want to do is multiply by all of those denominators to help us cancel out the fractions. So I'm going to multiply this entire equation by the 12, by the x, and by the x minus 1, so that's just all of the denominators put together. Now when we do this, we're going to have to distribute these things to each one of our fractions, and I'm going to write it out in the long form just so we can see what's happening. Now technically all of this stuff right here is over 1, so when I start distributing it in, when we multiply fractions, we multiply the tops and the bottoms. So when I take all of this stuff on top times this 1 on the top of the first fraction, then it's just going to be 12x and x minus 1, and then this is going to be over x, plus, now if I take all of this stuff times that 1 on top of my second fraction, then it's still going to be 12x and x minus 1, and this is going to be over x minus 1 this time. Now on the right hand side, if I take all of this stuff times the 7, then it's going to be 7 times 12x times the x minus 1, and that's going to be over 12. Now we're actually going to be able to do a little bit of canceling in here to get rid of these fractions. So as we look at this first fraction with the x on top and on bottom, those are going to cancel each other out. So then we would just have 12 times the x minus 1. Now if we look at our second fraction, we've got this x minus 1 on top and on bottom, so those are going to cancel each other out. So then we've just got the 12x left over. And then if we look at our fraction on the right hand side with that 12 on top and bottom, those are going to cancel each other out. So we've got the 7, the x, and the x minus 1. Now you've got a little distributive property to do to clean this up a little bit. So I'm going to take the 12 times the x to get 12x. 12 times negative 1 is negative 12. And then we've got this plus 12x. And then on the right hand side, I need to distribute the 7x. So 7x times x is 7x squared. And then 7x times negative 1 is minus 7x. We're going to be able to combine these 12x's on the left-hand side. So that's going to be 24x minus 12 equals 7x squared minus 7x. Now we've got that x squared in there, so this is a quadratic equation. And when we're solving a quadratic, we always want to get it equal to 0. So I'm going to subtract this 24x over to the right-hand side, and I'm going to add the 12 over to the right-hand side. So we get 0 equals 7x squared minus 31x plus 12. Now, we've learned a lot of different ways to solve a quadratic equation. We've done factoring, we've done the quadratic formula, we've done completing the square. This one is actually factorable. To get the 7x squared, we're going to need 7x and a regular x. Now this is going to be guess and check in here because of that 7x. We want to think about the things that are going to multiply to 12. So it's either going to be 1 and 12, or 2 and 6, or 3 and 4. But we have to keep in mind that our middle term is negative. So both of these are probably going to be subtraction in here. And what it actually ends up being is 7x minus 3 and x minus 4. And I can show you the check real quick on there. If I took 7x times negative 4, that would be negative 28x. And if I took negative 3 times x, that would be negative 3x. And if we combine those, we would get the negative 31x in the middle. So this is our factor set. Now because this is equal to 0, what we want to do is take each individual factor, and set them equal to 0. So the 7x minus 3 equals 0, and the x minus 4 equals 0. On this one, the first thing I want to do is add that 3 over to the other side, so I get 7x equals 3. And then we divide that 7 over, so we get x equals 3/7. And then on this one, the only thing we need to do to get x alone is add that 4 over, so we get x equals 4. Now earlier on, we did have to restrict down the domain, and we said that we didn't want our x to be 0 or 1. We didn't get either one of those answers, so both of these are going to be part of our solution set. Now here's another example of an equation that doesn't look quadratic, but we can use some quadratic techniques. Notice that we've got this square root of x in here, and we don't want x to be trapped underneath a radical, so we want to work on getting rid of that. Now anytime we've got an equation with a radical in it, we always want to try to get the radical alone first. So I'm seeing this extra x on the left-hand side, and I'm thinking we should subtract that x over to the right-hand side. So then we would get the square root of x equals 6 minus x. Now since x on the left-hand side is trapped underneath that radical, in order to get rid of that, we want to square the left-hand side, but then we're also going to have to square the right-hand side. And we're going to have to be careful because we're going to have to square the entire 6 minus x term. So now on the left-hand side, the square root and the squared cancel each other out, so we've got just x. But on the right-hand side, with this 6 minus x being squared, we're actually going to have to FOIL that out. So I'm going to write out another 6 minus x so we can see the foiling happening. 6 times 6 is 36. 6 times negative x is negative 6x. Negative x times 6 is negative 6x. And negative x times negative x is positive x squared. Now we can combine like terms on the right-hand side, so we get x equals 36 minus 12x plus x squared. Now because we've got this x squared in here, we want to get our equation equal to 0. So I'm going to subtract this x over to the right-hand side. Now as we're doing this, I'm going to rearrange this so that it's in power descending order. So this is going to be x squared minus 13x plus 36 equals that 0. Now this equation is factorable, so we get 0 equals. To get that x squared, we're just going to need a couple of x's. We want to think about the things that are going to multiply to 36 but add up to negative 13, and that's going to be negative 4 and negative 9. So then if we set each one of those factors equal to 0, x minus 4 equals 0, and x minus 9 equals 0. Adding the 4 over to the right-hand side, we get x equals 4. Adding the 9 over to the right-hand side, we get x equals 9. Now, anytime we're dealing with an equation that has a radical in it, once we get our answers, it's always a good idea to check our answers in the equation. So I'm going to go back up to the original equation, and first I'm going to substitute the 4 in. So we get 4 plus the square root of 4 equals 6, and we're just making sure that this works. Well, the square root of 4 is 2, and if I add 4 to 2, we do get 6, so 6 equals 6. So 4 is confirmed as an answer. So x does in fact equal 4. But then I also need to test 9. So 9 plus the square root of 9 equals 6. Well, the square root of 9 is 3. But if I add 9 to 3, I'm not going to get 6 as an answer. I'm going to get 12. So 12 equals 6. 9 does not check out as an answer. So 4 is the only solution to this equation. That's going to be it for this video. Thanks for watching.